Namaste, good morning everyone. How are you all guys? Today we will study the new chapter. In last lecture we have seen the latch using NOR gate. In this lecture we will see latch using NAND gate. So you all are very happy? You? Oh, very nice. Okay, see. So the topic is SR latch using NAND gate. So we have kept here two NAND gate, and this both the NAND gate, say the name, whatever you want to like, A or B. The output of A is given to input to the B of NAND gate, and the output of B NAND gate is input to the A NAND gate. And this process is known as latch. And we are seeing here, this is the basic latch circuit with the NAND gate. So, studying about SR latch, we should little recognize or remember the truth table of NAND gate. We have already studied. When the input of NAND gate are A and B, the output will be A dot B whole complement, or we can say A dot B whole bar. So when the input of A or B is equal to 0, 0, so 0 into 0, here I am writing 0 into 0 is equal to 0, and the complement of this 0 is equal to 1, so there is the 1. Again 0 into 1 is equal to 0, and the complement of that 0 is equal to 1. 1 into 0 is equal to 0, and the complement of that is equal to 1. And 1 into 1 is equal to 1, and the complement is 0. Here you don't think that 1 into 1 is equal to 1. This is the logical. So we should know that this is the on into on is equal to on, or true into true is equal to true. Like this, high into high is equal to high. So this is, and the complement of high is equal to low. So by this way, this is clear. Okay. So this is the truth table of NAND gate, and what we have seen in this NAND gate, the statement of the NAND gate we can generate by this truth table. If any one input is 0, the output is 1. Just opposite. If any one input is, see here, if any one input is 0, see 0 suppose, or both input is 0, this is 0, this is 0, the output is 1. Else 0. If all the inputs are only 1, then the output will be 0. Else any input will be 0, output is the 1. The opposite of input, that is the NAND gate. Okay. Coming here to the point. Now see, if S is equal to 0, in this first one case, and R is equal to 0, okay, here I have written S in the top of and R in the down. In NOR gate, I have already kept R and S, and here Q and N, so you should recognize this is for why I have written like this, due to it for the NAND gate truth table of the latches. So here is S, here is R, here is Qn, here is the Qn complement. S is equal to 0, R is equal to 0. Let's suppose Qn is equal to 0 and Qn complement initially will be the 1 opposite of the Qn. Now what will be happen? This Qn complement will come here, and this is 1, so this is the 1, 0 into 1. In this formula, if you will put, and you will see from the truth table of the NAND gate, when 0 and 1, if any one input is 0, I have already told you that if any one input is 0, the output is just opposite of opposite, that is 1. So here, this will be replaced and the output will be 1. Again this 1 will come here, 0 is already here, 1 and 0. Again here is 0, if any one input is 0, output is 1. So this will be the 1. This 1 again goes, because the loop, we have to complete the loop where it will be the stop. Again this 1 will come here, already 1 here, 0, 1, 0, it will be 1, 1, 1, 0. So what we are getting here? We are getting that 1 and 1. And this condition will never be happen. You know very carefully. If q is equal to 1, then q n complement will never be 1. It will be the just opposite. So this condition we are seeing here, this condition was came in NOR gate also, NOR latch. So this type of condition you can say this is invalid. Invalid, you don't know what is here, or not allowed. Okay. If we will see by putting 1, assuming 1, you can also see, no problem. If this is 1, this is 0, and this 0 will come here, 0 into 0. If both the input will be 0, the output will be 0, and this 0 will be come here, and 0 will be 1. This 1 will come here, 1 0 will be replaced by 1. This 1 will come here, this 1 and 0 will be 1. Again this 1 and 0 will be 1. So the same value is coming at the output at the next step. This one is the q, n plus 1 is the next step. So what we have seen here, in the NAND latch, when the s is equal to 0, r is equal to 0, it is invalid condition. Very good. So now we will see the next one, the other one, when the value of, sorry, I have written here a and b, sorry. This is s and this is r. Okay. So see, if s is equal to 0 and r is equal to 1, and assuming qn is equal to 0 and qn complement is equal to 1. So this 1 will come here, 0 and 1. If any one input is 0, the output will be 1. This will be cutted. This 1 will come here, 1 into 1. We will see that the truth table, it will be 0. 0 will become here, 0 into 0, it will be 1, already 1 here. This 1 will come here, 1 into 1 is equal to 0. Okay, now what is getting here? 1 and 0. When the value of s is equal to 0, r is equal to 1, in this case, we have assumed that 0, then it will be replaced by the 1 and 0. So here it will be the 1. And if we will suppose, if we will take 1, assuming 1, where t 0, now 1, it will be 0. So this 1 will come here already 1, 1 into 1 will be the 0, already 0. This 0 will come 0 and 0, 0, 0, 0, this is 1. So no problem. If already 1 in the Q and the 1, if it will be 0, then it will be 0. This condition will be known as, we said this condition 1, so we will say that this is set condition. Set condition. Now the next one, if we will see here, if s is equal to 1, r is equal to 0, and assuming this is 0, assume, and further we will assume 1. So this 0 will come here, and 0 into 0 by the truth of table, 0 into 0 it will be the 1, and already it was the 1, and 1 here, 1 and 1 into is equal to 0, already 0, 0, 1, already 1. So what was the last given? That value is coming here. Suppose we are assuming 1, and if here is the given complement is equal to 0, then what will happen? So this 1 will come here. Here this is 0. Now this we are repeat this one. So this is 0. 0 into 1 by the truth table in 1, that is the 1, and this 1 will come here, 1 and 0. So 1 and 0 it will be 1. This will be deducted. Again this will come here, 1. 1 into 1 is equal to 0, and this 0 will come here, and 0 into 0 is equal to 1. This 1 will come here. We will see that 0 in this case also 0, this case also, this goes to 0 and this is known as the reset condition. Okay? Are you getting? Okay, now the one. When the condition will be S is equal to 1, R is equal to 1 and we will assume here 0 and this is 1, what will happen? This 0 will come here, already the 1 is here, or the value of R is 1. So 0 into 1, any input is 0, so the output will be the 1, no problem. This 1 will come here, 1 is already there, 1 into 1 is equal to, this will be the 0. This 0 will come here, 0 and 1, 1, 0 and 1 is coming. Let's see the next one. If we are assuming that 1 and 0, what will happen on that? The same condition. This 0 will come here, already 1 here, so 0 and 1, we will see any one output is 0, the output will be, input is 0, the output will be 1. So here already 1. Again this 1 will come here, fit that, 1 and 1, it will be 0, already the 0, 0, 1, 0. So what we are seeing that, while we are assuming 0, then it was the 0. While we are assuming Qn is equal to 1, then it is the 1. So we can say this is the next state was the Qn. What was the previous? So we should write here, this is the Qn value, the previous value, and we will write here that is the hold state. It was holding the same state, or we can say previous state. By this way, this SR latch using the NAND gate, we have solved these all 4 conditions. 0, 0, while the 0, 0 invalid, 0, 1 set condition, 1, 0 reset condition, 1, 1 the whole condition. If you will see this table, what you will see that this is the just opposite of NOR gate. Sorry, NOR latch. Whatever we have just studied in the last lecture, the just opposite of the SR NOR latch. This is the NAND. So this is just opposite. And the lastly, we should know the graphical block diagram. We can say the graphical, this is equal to S, this is R, and we can say SR latch. This is equal to Qn and this is our Qn. This figure you can show symbol of SR latch. So till today, I hope you are getting very well. Little bit the lecture was large, but we have to understand very easily. So I hope you are getting very well. Thank you, my dear friends, my dear student, and you all have a nice day. Enjoy your day and remember our topic and our channel. For the best knowledge, you will get a lot of things on our channel. So subscribe our channel. Thank you. Thank you. All the best.